All right, welcome. This is lesson 5.3. Today we are going to find the common solution to a system of linear equations by using the elimination method. In the last lesson, we looked at how to use the substitution method. Now we're going to use the elimination method. And we also want to understand when you have to use multiplication to be able to solve using elimination. And we also want to identify the variable to be able to solve a word problem with a system of linear equations. So let's look at an example here. So solve the system of linear equations by using elimination. We have two equations, 3x minus y equals 9, and 2x plus 2y equals negative 2. And what the elimination process does is it allows us to get rid of one of these variables. We can get rid of either x or y. But in order for that to happen, one has to be positive, one has to be negative, and they need to be the same. Currently, these two equations don't do that, but this is 2y, this is negative 1y. If we just multiply this equation by 2, that would give us negative 2y. So we're going to take that equation and we're going to multiply the whole thing by 2. And now by doing that, we're going to get 6x minus 2y is equal to 18. So 2 times 3x, 2 times negative 1y, 2 times 9. We get that. And now we can put in our other equation, 2x plus 2y equals negative 2. And we can see that when we solve this, negative 2y and positive 2y are going to cancel out. And we're going to be left with 8x is equal to 16, and therefore x equals 2. And now we can solve for y by simply taking this 2, plugging it back into any one of these equations. It really doesn't matter which one we plug it into. I'm going to choose 3x minus y equals 9. We're going to plug that in. Y equals 9. And we get 6 minus y equals 9. And therefore negative y is equal to 3, which means y is equal to negative 3. So our two coordinates would be 2 and negative 3. Okay? This next example, we can do the same thing. Solve the linear equations. This one is much more straightforward. Notice that 3x and 2x, they're not similar, so we can't do anything there. But negative 5y and positive 5y, those will cancel. So I can write that out. 3x minus 5y equals negative 21 over 2x plus 5y equals 11. And so this is going to simplify. 5x is going to equal negative 10. Therefore, x is going to be equal to negative 2. And then to find what the y value is, we can take that negative 2, plug it into either one of these equations. It really doesn't matter which one. I'll just put it into the first one. So put 3 times negative 2 minus 5y equals negative 21. So that gives me negative 6 minus 5y is equal to negative 21. Add 6 to both sides. Negative 5y equals negative 15. So y is going to be equal to 3. So our two coordinates then are negative 2 and 3. Okay? So let's think about how does an elimination problem work? What if we wanted to write the steps? What would be the steps for an elimination problem? Well, step 1 is to make the coefficients of one variable same number, but opposite signs. So what we mean by that is, up here, we want to make sure that we have the same coefficient, 5 and 5 and 5, but that they're opposite signs, negative and positive. That way they'll cancel out. Step 2, add the two equations. And solve for one variable. Solve for one variable. Okay? And that's how we would get the answer for at least one variable, whether that be x or y. Then really we need a third step. So we're going to add a third step. And that third step is going to be plug that answer that we got in the first part, plug that into the equation. Or plug that into one of the equations from before and solve for the other variable. And that's how we can use the elimination process, the elimination method. In the next few pages, we are going to look at several different examples of how to use the elimination method and how it would also work with word problems.